Okay, so you might have seen factoring probably very shortly with the sum of two squares. So notice that if we have two squares here, a squared plus b squared um, equals something, how do we actually go through and solve something like that? So first thing that we want to take a look at is these different types of polynomials. So we look at the difference of two perfect squares. So difference, remember, means minus sign. So it's either this one or this one. And then it says the difference of two perfect squares. So x times x is a perfect square. 2 times 2 is a perfect square. B looks like the answer. X is x times x. But this one here, this is not the difference of two perfect squares because we can't figure out what multiplies to 5x plus 6. So it would be B. So when we're looking at that one, that answer would be B. Okay, so for the second part, we're going to look at x squared plus 4. So we can rewrite this. Now, we've done a problem like this just recently in the last video when we went through and solved it. What we did instead is we moved it over, then we took the square root of both sides, and we ended up with two answers, plus or minus 4i. So we're going to do kind of the same thing here. If I were to move that over to the other side, negative 4, we would end up with, we would end up in this case, a squared equals, haven't seen it rewritten this way. So we would have our a squared would be our values there. So I'm not sure what they're asking for in terms of how you write it. So I want to see how they're writing it in this particular case. So for this one, okay, so a squared would be our x squared, and the other one would be the 4. So they're just saying here's my a squared and here's my b squared. So that's an interesting way to write it. And I think we're just going to kind of keep going with the different problems. So our answers would be x plus the square root of negative 4 and x minus the square root of 4, which is really plus or minus 2i. So this should be a 2 here and a 2 here. I think that was a pretty complicated way to do that. I think I'll just stick with my way that I showed you before, and we'll just keep doing it that way. So let's go ahead and keep going with complex numbers. Okay, so here we have a plus, here's our a, which is negative 4, b is positive 8, a is 9, b is negative 1. Okay, so it just kind of shows you a whole bunch of different ways that we can rewrite some of the different problems. Not a big deal in terms of what we're doing on all of these. I want to go straight to problems to show you how they work. Instead of a lot of conceptual stuff, I think it doesn't show you quite as easily. So we're going to equate some complex numbers. So notice that we have these values here. We have 2x plus 8 plus y plus 11i equals 2 minus 4i. And how do we solve a problem like that? So here's our problem. 2x plus 8 plus y plus 11i equals 2 minus 4i. So the first thing I'm going to do is I'm going to rewrite this by putting parentheses around that first part. So I did that. So then the real part has to equal the real part of this side. So that means that 2x plus 8 has to equal to 2. So then we're going to subtract 8 from both sides. I get 2x equals negative 6. Divide both sides by 2. And x equals negative 3. On the other part, on the imaginary part, we can see that y plus 11 has to equal 4. So y plus 11 is the imaginary part. That has to equal, negative 4. So I subtract 11 from both sides. Y equals negative 15. So we get two answers, x equals negative 3, y equals negative 15. And then, of course, what do we assume? We assume that y is real, and x is real, and y is real. So we assume these two terms are real and not other imaginaries thrown in there, but x and y need to be real for this to happen. So negative 3 and negative 15. So x and y are real numbers, and we get x is, I want to make sure I get these right, negative 3 and negative 15. So if I come back over here, negative 3 and negative 15. And if I check my answer, those are okay. If I check my answer up here, I'm good on B. So I just want to make sure that I get those correct, make sure that we're understanding how to be able to get those particular values. So, okay, so let's move on to the next resource. Okay, now we're going to add some complex numbers or subtract them. If they were subtracted, I would, of course, distributed the negative through. I can distribute the plus through, but it doesn't make a whole lot of sense. Actually, I think I'm going to leave it in blue. And so I get 3 minus 7i plus 1 plus 11i. All I do is distribute the positive through. Doesn't mean, it means nothing changes. Now I'm going to combine like terms. That's 4 plus 4i. And I can't combine anything else. So this would be my answer, 4 plus 4i. So it would be B. And we get B. Okay. Next thing is multiplying. So I'm going to go ahead and multiply the values. So here I have a voltage is equal to a, this is a current, and I can't remember what C stands for right offhand. I should know. Oh no, current is C and impedance is I. So we have impedance, which is I. So here is C and I. And notice that they use the variable J, not the variable I. Okay, in a lot of problems, you'll see them use different things at different times. We're going to go ahead and use J just to show it. Doesn't really matter, to be honest with you. So we have V equals, so I'm going to substitute 2 plus 5J, which is really just an I, and 3 minus 4J. We're going to FOIL. So 2 times 3 is 6. 2 times negative 4 is negative 8J. We're then going to FOIL or distribute the 5J through. 5 times 3 is plus 15J. And we have positive 5 times negative 4, which is negative 20. We have 2 J's, so we have a J squared. Remember that I squared is negative 1, so this J squared is also negative 1. So that's also negative 1, so we have 6. We can combine these two are like terms, plus 7J. We have minus 20 times negative 1. Sorry, my dogs are playing. And then 6 plus 7J plus 20. Remember that J squared became negative 1. So we have this one right here. So 6 plus 20 is 26 plus 7J. And we end up with an answer of this one right here. And then we'll move on to the next one. Our last problem is dividing complex numbers. So we have 7 minus 3i divided by 6i, and we want to divide those. Now we cannot have an I term in the denominator, so this is what is known as rationalizing the denominator. You can also kind of think of this in a way as 7 minus 3i over 0 plus 6i, where we just change the, notice we just change the sign of the imaginary part in the denominator. Then we multiply top and bottom. That's not an efficient way to do it, having that 0 there. So just so that you kind of see it, we are multiplying by negative 6i over negative 6i. And of course, negative 6i over negative 6i is 1. So we can multiply anything by 1 and it won't change the problem. But we aren't going to cancel those. We're going to distribute the top through. So negative 6 times 7 is negative 42i. 7 times negative 6i. Negative 3 times negative 6 is positive 18i squared. So we have I times I, that's going to give me I squared. In the denominator, I have negative 36i squared. Okay, now we know that I squared equals negative 1. We've learned that already. So we have negative 42i minus 18 because I squared is negative. We have another negative down here, so we have positive 36 because we have negative 36 times negative 1. And then we have to reduce. Now when we're reducing, Everything that we find has to go into all three numbers. So I know that 2 goes into all of them. So that's negative 21i minus 9 all over, and then that divided in half is 18. Okay, so we factored out a 2 out of all of them. Now we can see that 3 goes into all of them. So we're going to do it again. So that's negative 7i minus 3 all over. 3 goes into that 6 times. So it'd be negative 7i minus 3 over 6. Okay. Notice there's a little similarity here. We won't talk about that yet, but there is a little similarity as we kind of go through this. So this would be my final answer, negative 7i minus 3. Well, this is it, I squared, but that's not how they should write it. And actually, I think this last one is the one that's going to work, because what they do, and I didn't do that, negative 7 over 6i minus 3 over 6, right? When I have fractions, I can rewrite them as separate terms, which is what I did. I just put the 6 under each number, and I get negative 7 over 6i minus 1/2. So it should be negative 7 6i minus 1/2. Notice this one's close, but notice we did not get rid of the I squareds there. So you have to be careful with those. Okay, so make sure that you know how to do those. I'm actually not going to mark it there. I'm just going to look at the answer and make sure it's D, and it is D. So that's it. Last check, and we are done with this section.